My name is Florian Kunzer, I'm sales engineer at GmbH. For me, it's the first time here at RPM, so maybe you can give me an introduction of what you're doing.
Sure. RPM was founded in '97 as a pure prototype company using SLS technologies these days. We developed over the last more than 20 years into a full service provider which assists our customer today in all phases of their product development using additive technologies, casting technologies, or CNC milling, for instance. There is a strong wish going directly from CAD data to product without any tools. So we focus on additive technology. This part cannot be checked with conventional methods. So for this one, we would use the GmbH ScanCobot.
So I see you use the ScanCobot within ATOSQ.
Yeah.
Up to 12 million single measuring points per each scan. We see the scanning positions are calculated now for us, and we can use this directly to measure our first part.
Absolutely. Just click the button and do the scan. Start movement, and that's it.
So you produce a lot of parts, and of course we want to check these parts inside one step, so maybe we can do this now.
Okay.
Okay, let's see how it works.
Okay. Just an easy click here, and the scan starts. Interesting is that we also could see some of these lines or over the whole part. This characterizes the layer by layer manufacturing using the sintering process.
So we can see the positioning inside the building chamber.
Absolutely. There is a standard form as a report for our customer in future. Looking into the results of the part, we will have first a look into surface deviation. Means we have a comparison between the digital twin and the CAD data to show deviations from that. Our goal is in future to build as much as possible parts with additive technology in serial stage. When we look into the comparison of these three parts, we could see slightly differences, but to make this more visible, we switch again to the surface deviation tool. And here, looking at the three different parts, we see that those are slightly different. So we put these two digital twins together here. As we have two sets of data, two parts, put them together, we are able to look into the part. And this is an interesting function to check if there are imperfections or some criteria not fulfilled for function of the part.
We saw a lot of solutions building up fast digital twins, see a lot of solutions inside the GmbH software via part-based and stage-based evaluation.